privileged to address the resource person on behalf of Department of Computer Science and Application, Gandhigram Rural Institute, Dept University. We welcome all the participants in the workshop. We are truly delighted with your presence. We all have gathered here today to attend this workshop to enhance the recent techniques and applications of AI. This workshop intends to provide useful resources for budding researchers. The secret of getting ahead is getting started. We are profoundly delighted to take an opportunity to introduce the esteemed resource person, Dr. Deepak Garg, Project Director, Leading India AI, and Head Department of Computer Science and Engineering, Bennett University, Greater Noida, India, for the first session of AIMS 2022. He is the Chief Consultant of Algorithm Guru.in. He done his PhD in Efficient Algorithm Design in 2006 and served as a chair of IEEE Computer Society, India IEEE Education Society in 2013 to 15. And he had handled funding of around 700 million, including RAENG, UK, on Move, Machine Learning, and AI. He has 100 plus publications with 850 plus citations and Google Hutch Index of 70. In his 20 years of experience, he has delivered 300 plus invited talks and conducted 100 plus workshops and 15 plus conferences across the country. He has supervised 13 PhD and 35 PG students. He is a blogger in Times of India named as Breaking Shackles. We welcome you, sir, for the first session.
Okay, can I share my screen?
Yes, sir.
Okay, is it visible?
Yes, sir.
Okay, so good morning, everyone, and my sincere thanks to the organizers, professors of the department who has invited me, and some of them we have met previously, and it is nice to be connected again and deliver a talk on this. So today's talk is on explainable AI and challenges, which is one of the critical areas now in the field of artificial intelligence, because many of the artificial intelligence projects are stuck because we are not able to solve the problem of explainable AI. So let me make you some understanding of what is explainable AI. So explainable AI assumes that AI system by design are probabilistic. So that means you will not get the exact answers, but you will get the answers which are true with certain probability. For example, many times you say that my AI system is 95% correct or 87% correct. So that means AI system will make mistakes, and we need to take that into account, that mistakes will be there. And when we are using the AI systems in systems which are safety critical, where human life or human health is at stake, there we have to be more cautious about understanding the explainable AI. So previously we used to use rule-based methods which were explainable, but which were not accurate. For example, decision tree systems, or we were using some naive-based classifiers. While the neural network system that we are using, they are more accurate than the rule-based methods, but these neural network-based methods are not interpretable. So let us assume that there is a simple classification in an AI system where we want to classify the images, and the system has classified a particular image as an elephant. So here the question any person who has the understanding of explainable AI, he will ask the question, why this system has given that classification? Why it has not given something else? Why it has not called it as a dog or a cat? Why it is calling it as an elephant? And when this system succeeds in interpreting a classification, and when the system fails, we don't know. And when we can trust the system, how to correct the mistakes. So all these questions are very important from the point of view of the user, as well as the developer, and as well as the regulator. So if the system says, I selected elephant because it has a trunk, it has a tail, and it has big ears, then I am much more confident, and it creates more trust in me regarding that classification than just saying that it is an elephant. So explainable AI comes from three different fields in AI. So any AI model has three important categories. One is the data is the important part of the any AI model, which is we call as explainable data. And then the output in terms of predictions or classifications, which we call as explainable predictions. Then the algorithms that have been used to convert data into predictions. So these are the three things in which researchers are looking at, that how we can make a model explainable. So basically means what data was used to train the model and why that data was used, why not something else was used, whether the data was properly distributed in a normal curve, whether the data was having lot of variety, whether the data was unbiased. So those all things we need to check out. And in the explainable predictions, we will see that what features and weights were used for this particular prediction. And in the algorithms, we will see what are the individual layers and threshold used for a prediction. So as some of the speakers, including Vice Chancellor, have already said that AI is having very huge impact on our life. So we need to see that how we are being impacted by artificial intelligence. So actually the impact is increasing day by day, and it is becoming critical to the point that now we are becoming slaves of artificial intelligence. Because AI is already making some decisions and we are not able to make those decisions. We are being forced, or we have become so addicted, or we have become so unaware that somebody else is taking decisions for us. For example, the Facebook AI algorithm is deciding that which video we should see. So it will almost kind of force you to see some videos, because it understands your interest, it understands your psychology, it can check on your history, what you are searching in Google, what you are trying to see, on which videos you stay, which videos you have seen fully. So with all this information about you, AI algorithm is selling your attention span. It is selling your time to the potential advertisers. So that means you are being used as a product in this whole story, and you are not being paid anything. Similarly, AI algorithm in Amazon, it is recommending you the product which you should purchase, and many times you end up purchasing something which initially you were not planning to purchase. So you, for example, let us say you opened the Amazon app and you were trying to buy some clothes, and because of the algorithmic recommendation, you end up buying some furniture also, or you end up buying some electronics item also. So like that. Netflix AI algorithm is recommending which movies you should watch. So that means AI is deciding what you should buy, what you should watch, and which video you should see. Similarly, Google Map AI algorithm is deciding which route you should take to go from one place to another place. And similarly, AI algorithm is guiding you to whether to take the umbrella to office or not, whether to go out at this particular point of time because there may be some rain coming, there may be some thunderstorms coming. So weather AI algorithms are also guiding you when to go to office, when not to go to office. Dating and matchmaking sites are recommending your life partners. So many crucial decisions of your life are being decided by artificial intelligence algorithms. So it is a very interesting state, interesting time in the society that we are in such a complex world and technology is taking so many decisions for us. So let's go to further section. So, for example, you are using AI in the health system, and you are using a stroke data set. So now it says that after checking your physiological parameters that there is a 90% chances of stroke. So it may be a shock for you. You just go to the hospital, you get yourself checked, and the answer is that you have 90% chances of stroke. So actually more than this information, because of this information, you can get a stroke. So this is not something we are looking for. For example, when you go to a doctor and doctor just say to you that you have 90% chances of stroke without giving any reason, without giving any explanation, that is very bad. So what to do? Similarly, let us say you are going to a bank. The bank says either your loan is approved or your loan is rejected. But you don't know why it has been rejected, why it has been approved. Similarly, AI is also making some very serious decisions in life. It is driving your cars in some countries, it is driving drones, it is driving trains. So that is very serious thing that AI is intervening in our life. So when AI is going to make most of decisions for us, then it becomes very important to understand why AI is making a specific decision. So the solution is explainable artificial intelligence. So humans simply need to understand what is going on inside their algorithms. And that is exactly where explainable AI comes into play. So we want to know why the algorithm is taking a particular decision. And this research field is also called interpretable machine learning. And some people also call it as explainable AI. So it provides techniques to better understand and validate how our machine learning models work. Otherwise, many people call it as a black box when we are using neural networks. So the interest, the research papers, citations in the field of interpretable machine learning or explainable AI are increasing month by month. So you can see that how the graph of explainable AI in terms of the number of papers, number of citations is increasing. So artificial intelligence is very important for the end user. It is very important for the AI developers. It is very important for the regulators. So let us see for the end user. So if somebody says you have 90% stroke, but now you want to know that why 90%. So if explainable AI can come up with some details that your stroke chances are high because your age is more than 60. Or it can say because your body mass index is greater than 35. Or it can say because you have hypertension. Or it can provide details like your stroke chance is high because your age is more than 50 years and you are diabetic and also have high glucose level. So this is some explanation where it will give you more trust in the system. So similarly, it can also give you some counterfactual explanation. So what can be the counterfactual explanation is that right now your prediction is 90% stroke. If you will decrease your body mass index to 25, the prediction will be 70% no stroke. So that will give you even much more confidence that if you can now work out that do something so that your body mass index goes from 35 to 25, then the chances of stroke will go down from 90% to 20%. Sorry, 90% to 30%. So it says 70% no stroke. So similarly, in the case of loan application, the counterfactual example can be that as of now your loan is rejected, but your loan can be improved if you increase your income by $10,000. So this kind of explanation in an AI model is known as counterfactual application, counterfactual explanation. Or it can also say that increase your income by $5,000 and have one more year of credit history, then also your loan can be approved. So this is another example of counterfactual explanation. So why the explainable AI is important for the developers? For the developers, it is important because many times they don't know that why their system is behaving in the way it is behaving. So let us say you have these many images, and you are trying to classify the images into either wolf or husky. So these are two different kind of breeds. So either in the image you have a wolf, which is categorized here as W, or you have husky, which is categorized as H. So now after some time you see that there is an error in this system, and one of the images, which is husky, actually has been classified as wolf. So how you will find out that why the system made this error? So by using some explainable AI, you did some research, and then the system came out with this answer on the right side of it, that it has shown it as wolf because there is ice in the photo. So the resultant conclusion from this is that eventually, if you go back in all the systems where we have shown the image as a wolf, there is a ice in it. So that is a problem in the data, that all the examples that we have provided to the system where we have labeled it as wolf, all those images are having ice. So the system has just found out that wherever there is an ice, just call it as a wolf. But that is not the true classification. So that you came to know because of the explainable AI. Similarly, for regulators also, explainable AI is very important. So European countries has implemented general data protection regulation guidelines. So which establishes the right for all individuals, means it is your right to obtain meaningful explanations of the logic involved in any AI system when the decisions are being made by automated algorithms over individual decision making. So this is very important. This has given the customers or the users of AI systems a fundamental right of explanation. So whatever system you are making, it will become very important that if you want to make it a global system, then you have to follow GDPR rules. And if you want to follow GDPR rules, then you have to make your system with explainable AI. So here is one example where regulators wanted AI system to find out that all the offenders in the jails of US, when they come out, how likely they are again likely to break the law again. So this kind of survey was done, and an AI system was built which was known as correctional offender management profiling for alternative sanctions. So when the system was implemented, they found that the system is very much biased. So Compass was only moderately accurate in identifying white and black recidivism about 60% of the time, because it was having the errors which were reflecting the biases in the system. It was biased against the black offenders, and it was in fact wrongly being identified as lawbreaker than the whites, which was a false negative. So that is why it is also very much essential that the regulator should know that why your system is giving this particular answer. Otherwise, you can end up charging a wrong person. So explainable AI is artificial intelligence in which the results of the solution can be understood by humans. It contrasts with the concept of the black box. Why an AI has arrived at a specific decisions. So explainable AI may be an implementation of the social right of everybody to get an explanation from the system. The explainable AI, that is why it's known as the basic building brick for preserving and expanding the human autonomy and helping humans make better decisions. So this, I think, makes it clear that why explainable AI is very important. So to sum it up, we can say that explainable AI is to empower individuals against undesired effects of automated decision making, and also to implement the right of explanation as per global data protection rules, and to help make people better decisions and better AI systems, and also to preserve and expand AI. So let me stop here for a moment and see if there are any questions from the audience. So then we can move to the next section of our talk. So any questions from the audience, you can please write in the chat box. Yeah, any questions from the audience regarding anything about explainable AI, or in general, if you have any questions about AI? So we have a question from Professor Mary Shanti.
Yeah,
Okay.
yes, sir.
Hello, Professor Mary. How are you?
Yeah, I'm fine, sir. Hope you're also fine.
Yeah. So I am going to answer this question because this is coming up in my next slide.
Okay, sir. Okay, sir.
So when we want to explain a black box explanation, we have four different kind of things that we can get help from. One is known as the visual explanation, another is known as feature importance, third is known as data points, and fourth is known as surrogate models. Feature importance section of it. So let us go one by one. First is the visual models. So visual models produce different sorts of explanation, starting with the correlation plots or other visual methods. So for example, let us say if we have two features and we want to show the correlation between those two features based on our AI model. So there can be 6 different types of relationship between two uh, features. They can be strongly positively correlated. They can be weak positive correlation. There can be strong negative correlation, weak negative correlation, moderate negative correlation, or no correlation. So once we understand these details, then, for example, when we said that you have 90% the chances of stroke, so if it is directly correlated with the age of the person, so age of the person may have a strong positive correlation with the chances of heart attacks, or it can have moderate negative correlation, whatever it can be. So similarly, if there are 100 different parameters you are using in the system, so all those different parameters can have different kinds of correlation with the output that you are looking at. So that can be one way of looking at that, how you can explain something that which you are getting. Now let us come to the second part of is the feature importance. So the feature importance is that which features in your AI model are more important, and this is also known as feature summary. So for example, here we are making the chart about feature importance from a same application, which helps us to find out the stroke in the patient's chances of stroke. So the first is the age parameter. So you can see the age is most important feature while understanding the strokes. So 60% importance of age is, that means it is very strongly correlated to the chances of stroke. Then the next is about average glucose level, hypertension, heart disease, body mass index, whether you are married or not, what are the type of work that you do, whether you are male or female, whether you smoke or you don't smoke, and which kind of area do you stay, whether it is polluted, not polluted, those kind of things. So you can see that there are very weak correlations in many of the parameters, or there is very moderate correlation, but for age there is very high correlation. So this is another way that will help you to explain your result. And the third is data points, where you say return data points that help us to better understand the model. So this is known as the what if tool. So what if tool is a tool provided by the Google, where you can go to, I mean, this is available online also. So you can keep on changing some of the values of your parameters, that if this particular parameter changed from this value to this value, then what will going to happen. So this what if tool gives you a very visual explanation of that how the system is performing. Then we have the surrogate models. That means surrogate model is that building a simple model around the complex model. So let us take this example. So on the left hand side, you see a complex model, and on the right side, you see a very simple model. So if you are trying to understand a particular point, so for example, we were using as a sample one person who has got an explanation from the system that he is having chances of 90% stroke. So we understand that and want to give a counterfactual application to this point. So we have made a simple model around this complex model. So we have hidden everything else, and we now concentrate on the red box, and we have expanded that box, and now we will see that how we can do this. So we will on this. So these are the four types of different categories. One is known as the explanation type, so which is visual, feature importance, data point, surrogate models. So these four we have just seen. Then there can be another explainable AI methodology, which can be based on the data type. So whether you are using text data or tabular data or image data, or another method can be based on that whether the technique that you are using for explainable AI is model agnostic or model specific. So some can work on, let us say, a CNN model, some can work model, some may be working on a sport vector machine, and so on. Then whether the explainable AI technique you are working, it is on a low. So let us talk about agnosticity of explainable AI model. So one is model agnostic, another is model specific. So model agnostic means that the explainable AI algorithm can be applied on any kind of model. For example, local, interpretable, model agnostic explanations. This technique is known as line. And then there is another technique known as Chaplain additive explanation. This is technique is known as SHAP. So we will be discussing these two techniques. So these both techniques are model agnostic techniques. That means they can be applied on any model. They are not specific to ANN or CNN or ride on anything. Then we have model specific techniques. So there are two techniques known as layer-wise relevance propagation and integrated gradients. So these are model specific techniques. So that this method was designed for a specific type of machine learning model, such as only for neural networks. So that talks about agnosticity. If we comes to now how the scope of the model can be different. The scope refers to either aiming to explain the whole model which we have built or just parts of the model. So for the instance of the individual prediction. So if we are looking at the individual prediction, or we are talking about a person X, or about local explanations. And if we are talking about the whole model, then we are talking about the global explanation. So here is an example of a local and global interpretation. So if you are looking at the whole graph, then you are talking of the global interpretation. But if you are looking at only a specific point in the graph, then you are looking at a local interpretation. So global interpretation is being able to explain the conditional interaction between dependent variables and independent variables based on the complete data set. While the local interpretation is being able to explain the conditional interaction between dependent variable and independent variables only with respect to a single prediction. So that is the difference between local and explainable AI from child also, right? So we have covered these 4 different points: visual, data points, feature importance, and surrogate models, and also talked about different explainable AI categories based on data type, scope, and agnosticity. So now we will specifically come to a particular technique which is known as line. So before I start this again, I will just stop for a moment and see if there are further questions. So any further questions, please write in the chat box.
Yeah, participants, if you have any questions, you can kindly post it in the chat box. So there are no questions, sir. So kindly proceed, sir.
Okay. So we have line, which is the local interpretable model agnostic explanations. So line is basically used for explanations on single instance of data. Objective is to provide human understandable explanation of the model. So it is based on the 2 principles of trusting the model and trusting the prediction. So let us say we have a loan approval application to understand the line model, and the parameters are loan ID, gender of the person, whether the person who is taking the loan is married or not married, how many dependents that person has, what is the education of the person, whether person is self-employed or not, what is the income of the applicant, how much amount he is looking for, he or she is looking for, and the credit history of the person. So let us say, to make it simple, we are working on two features. One is applicant income and another is loan amount. So based on the two features, you can see the graph. So this graph means you will not be able to explain it because it is not a linear curve. It is very difficult to make some clusters out of it. So the figure is showing us the decision boundaries after training of the model. So by nature, even if you are just taking two parameters, the model is highly uninterpretable. And if I include all the parameters that we have discussed in the previous slide, then it is very complex model and impossible to explain. So it will be very interpretable. So simple solution is to build a simple model around it based on local solution without worrying about the rest. So what we are doing is here, let us say you want to interpret this red point given in the graph. So we expanded that graph and we forget everything else. Every other area of the graph is now hidden from us. So now from this graph on the right hand side, you can see that this particular red dot. So if we move it slightly on the right, then it will go into the gray area. So on the horizontal axis, we have the loan amount term. So that means if the loan amount term is increased by some fraction, then we will go into the gray area and the loan will be approved. So what we say is that it fits a linear interpretable model in local area known as surrogate. So this right hand side graph that you are seeing is known as the surrogate graph. It is local approximation to our complex model. And it can work with most of the data types, and it can help the users to build trust on the model and predictions. So that is what the line does, that we take just a relevant portion of the graph and try to understand it. So you see that from this graph, you can also understand that if we decrease the applicant income or if we increase the applicant income, it will make no difference in the decision because you can see the boundary of the gray area. So if you increase the applicant income, still this will remain in the white area and there will be no change. So from here you can also understand, apart from simple explanation, you can also understand counter explanations. Then let us come to the another example that is known as Chaplain additive explanations. So Chaplain additive explanations are based on the game theory and depends on the principles of marginal contribution of each parameter in the neural network. So what we want to understand from here is that what Professor Mary was also talking about the contribution of different features. So here, if you are having 4 people in a football game, just for simplicity, we have taken 4, otherwise it can be more. And let us say there is some prize money if they get the first prize, and the prize money is $1,000. So the question here is that how those $1,000 should be divided into 4 players. So let me see if somebody can try to guess that how we will divide this $1,000 into 4 players. Anybody wants to try to answer the question?
So depending upon the contribution by each player, sir.
So how we will find out the contribution?
Yeah, we try to remove any one teacher or player, and then see what will be the outcome.
Okay, so that is naturally the first reaction every time I see from the audience. So, and that is that if we remove, let us say, player in the yellow clothes, then I can say that ability of team winning the first prize. So that means if the yellow cloth player is not there, then at most the team can win second prize. And the first prize was $1,000. So that will mean that the player in the yellow clothes is worth $700. So, but that may not be the only solution. This particular query. So, because the reason is that somebody else may answer this question based on that. Let us say we can see which player has done how many goals. So let us say if one player has done all the 4 goals, that means he cannot take the all $1,000, because there was somebody, if he was playing in the front, there was somebody playing in the middle who was supplying the football to that player. If that middle player, then there will be no possibility to stop the goal. So if they could not have stopped the goal, then the other team may have done maybe 10 goals. So what is important here between the players? So what we will see here, between player 1 and player 2, player 1 and player 3, player 1 and player 4, similarly player 1, 4, player 1. So we cannot just go by the importance of each player. So we go by calculating the player contribution for each subset. And then we simply average over all of these contribution. And this gives us the marginal contribution of a player, also known as the marginal value. This means maybe we can also show it mathematically, but we don't have that much time in this session. The same concept we have to extend. We have to extend for our features. So let us say these are not players, but these are features of our model. So if we have 4 features, then we have to say that how feature 1 and feature 2 are contributing, how feature 1 and feature 3 are contributing, feature 1 and feature 4. Similarly, feature 1, 2, 3, feature 1, 2, 4, feature 1, 3, 4, feature 1, 2, 3, 4. So let us say if there are 4 such features like age, gender, body mass index, whether the person has diabetics or not. So size may be the prediction. Distribution is known as the Shapley value, which is also the name of this technique. And we will know the contribution of each gender plus BMI, age plus gender plus BMI, and hundreds of such parameters. That case, it becomes very complex. So counterfactual explanations in real life situation, a company who may have at stake never like to make public the details. To say is that you start telling the persons that why you are getting not getting so much stroke chances, then after some time the whole information about that system or the system will be changed. So we do not like to tell all this. So there has to be some balance of this, because then it will not be commercially viable to tell all information to the consumer. So means you are now stuck in between the two requirements. One is the legal requirement that explanation to the customer, the right of the customer to get the explanation. And another side of the story is that if you are telling about your machine learning model, then it is also a threat to the survival of your business. So for example, let us say you have a or fake news identification. So if you start telling the user that why your content has been identified as fake, then the same same hint can be used by the persons who are creating fake content. So they can again improve their logic, their algorithm, and can produce something which cannot be identified by fake content identification system. Similarly, if you are telling everything about the system which is approving your loan or rejecting your loan, then after some time you will find out that all loan cases are being approved, because now the customer knows everything about the loan approval system. So in that case also your bank will be in a problem, because you may be giving some loan to some persons which will never come back and which will become bad loans. So this is a two-edged problems, that why one is that on one side it is that it is the right of the customer to get some explanation, and on another side it is threat to survival of your business. So counterfactual explanation also says that no need to look inside the black box, just read the algorithm or read its code. So counterfactual explanations are considered better than the simple explanations, because here we are saying that the customer is not allowed to look inside the black box, and we only see that what features need to be changed and how much we need to change to flip the prediction of the model. So this is not that simple. So depending upon the complex application, the methodology will be different. For example, here we have counterfactual explanations where we say that if you have a BMI body mass index, which is 34, if you can change your body mass index to 25, then there will be no stroke. So these kind of counterfactual explanations are very important. So counterfactual explanations means we need to understand that whether we can generate it automatically or whether it needs to be inbuilt into the system, because generally the systems will have hundreds of features which needs to be engineered, and there will be many interlinkages, and making it too simplistic, you can also kind of sometime oversee, or you can forget some of the important ingredients of the system and can give a wrong explanation to the user also. And many times there may be multiple counterfactuals based on different features. So you can say, for example, here that one is that if your age is this, that is why you are getting stroke. Then you can say your BMI, then based on gender, then based on diabetics, based on maybe your some other features, and there may be multiple counterfactuals possible. So again, the question will be that what you should tell to the patient, which particular counterfactual explanation should be given. So again, there is research work going on in this area, which is trying to understand the counterfactual bias related to set of users based on their demography. So the counterfactual recommendation that you are giving to the user also has to be unbiased. So For example, if you are saying to somebody that reduce your body mass, so that user may feel offended that people are trying to target his body shape. So that can be again a biased opinion, or there can be some other such areas of concern. For example, when you are saying fake news identification, there can be some comments related to some particular community, or there can be a fakeness being created because it is being originating from a particular region. So those kind of biases we need to avoid in our understanding. So if you are able to create a bias-free counterfactual explanation, that is sometime also known as global counterfactual explanation. Then we come to the layer-wise relevance propagation technique. So layer-wise relevance propagation technique, LRP, is specific for neural networks and based on the assumption that classifier can be decomposed into several layers of computation. So it helps to understand the relevance of specific features for arriving at the classification. So we can understand what is happening at the first layer, what is happening at the second layer, what is happening at the third layer, and so on. So the classifier can be decomposed into several layers of computation. So if we see here, if you have image X, and if you are checking this classification, then you can also do a reverse engineering and you can understand the pixel wise explanation. So you can see some hot areas, hot pixels on the right hand side, that which are the important pixels which are helping this image to be classified as cat. And then there are some areas in the blue which are known as pixels which are not helpful for classifying it as cat. So depending upon which pixels dominate, the classification will result in that particular classification. Because if there is more than zero 0.5, more than half probability of this image being cat, then it will be shown as cat classification. And if it is less than 0.5 probability, then it will be shown as the some other classification. Then there is another category which is known as contrastive application. This is very new and innovative and important. So a team from IBM research came up with this path-breaking idea. So till now, all of us were imagining AI models based on available data and features, but they tried to imagine AI models based on missing features. For example, if they are saying that Murugan is a tall guy with short hair who does not wear glasses. So this kind of classification is unique, because generally in any AI system we will say the person is Murugan because the person in the image is tall and with short hair. But here we are also adding one parameter which is missing. So we are not saying that he is wearing glasses, but we are saying because he doesn't wear glasses. So there are no glasses in the image. So this is something which is a new innovation in the field of contrastive application explanation. Because if there is another guy who is tall and has short hair but also wears glasses, so this will become another point for differentiating two persons. So that means the missing features may also be helpful in classification apart from only the features which are available. So in our common human interaction, these types of descriptions are common, where we also mention some missing features. For example, we say that that person's looks like this. Sometimes we say that person doesn't have hairs on the head, or we can say some other features which are absent. So Now many people can come up that it is very challenging how to make an exhaustive list of possible absent features. But the researchers have also worked on this, that you don't need to make an exhaustive list of possible absent features. You only need to have some minimal set of features that help distinguish from the closest class that it does not belong to. For example, the example that we used on the last slide, that person wearing glasses and person does not wearing glasses. So if we do a mathematical explanation of this contrastive application, so let us say X is an input to classify. It can be an image. And Y is the class the model predicted for X. So if Y is, let us say, the output, in this case, it can be the output that the person is long, person is having short hair, and person is without glasses. So if F are the set of features that are present, and M is the set of features that are missing, and X is classified in Y because F and M both are true. So till now, in all the AI models, we were only looking at features which are present. But in this kind of model, we will also look at features which are missing. Then there is something known as pertinent positive and negative. Pertinent positive is a factor whose presence is minimally sufficient in justifying the classification. But we are adding a new term which is pertinent negative. It is a factor whose absence is also necessary in asserting the final classification. So this contrastive explanations has given rise to a new kind of models that are coming up in the AI systems. So for example, a patient with symptoms of cough, cold and fever, but no sputum will be diagnosed as flu rather than pneumonia. Because if the patient has only symptoms like cough, cold and flu, that means that person can have both flu and pneumonia. So, but if the person does not showcase his sputum, then only it leads to diagnosis of flu. So that means sputum here is pertinent negative parameter. So here you can see that we have an image. It is a digit data set where we are trying to predict what digit it is. So specifically in image 3, if you see, we are also showing a pertinent negative that this is not 9 because those pixels which are shown in this violet color are not there. And similarly in second image, we are showing pertinent positive. And in fourth image, we are showing LRP layer-wise technique, and in the fifth, we are showing lime technique. So this is what we have discussed till now. So we have discussed the visual models that produce different sorts of explanations, starting with correlation plots. And we have also discussed feature importance, the information about the feature importance, usually called feature summary. And we have also discussed data points and also discussed surrogate models. It can be used to derive explanations and calling surrogate models. So this is what I wanted to share you about explainable AI. I am open to questions now.
So good morning, sir.
Good morning.
Yeah, my question is, will incorporating explainability increase the model complexity?
So explainability is to get a insight into the model. So we are not means increasing anything in the model itself. Explainability is post building your model. So we are not adding into anything into the complexity of the model, but we are trying to unravel the model. We are trying to open up the layers of the model. We are trying to find out some useful explanation for the user. So for example, let us say if you are means one of the patient is going to an hospital and there is a health system implemented in the hospital which detects whether the patient has cancer or not. And if the model is 95% correct, that means there are 5% chances that model will be wrong. So let us say if one patient got either false positive or false negative result, then that is a disaster for that patient. So where that patient will go, where he will complain, from where he will get the compensation, and who will be responsible for this kind of wrong result being given to the patient. Whether the software developer will be responsible, whether the CEO of the company who has developed that system will be responsible, whether the team lead or the researcher who developed that algorithm of AI will be responsible, or the hospital management or doctor or nurse. So there are hundreds of people in that ecosystem. So it is very difficult to find out the reason that who will be responsible. So that again puts back on the importance of understanding the explainability, that why that particular patient only got the wrong result, why that particular patient only got the right result. So that is important to understand.
Yeah, okay, sir. Thank you.
Okay, anybody else, any questions?
Any questions from other participants?
Okay, then thank you very much to the organizers again.
Thank you, sir. So we thank Dr. Deepak Garg, sir, for delivering his wonderful and information session. So he had nicely presented the basics of AI and their challenges in an effective way. Thank you, sir, for your wonderful presentation.
Okay, thank you very much.
Thank you, sir. On my behalf, I extend my heartfelt thanks to you for supporting us in all our ventures, for hand-holding us throughout our AI journey. So the development in AI research in our department is completely dedicated to you, sir. Thank you so much.
My pleasure. Thank you for your comments, and I am there for any further help you need. Thank you.
Thank you, sir. Thank you. Thank you.
So participants, we have posted the feedback form in the chat box. So kindly fill the feedback form in the end of every session. Your feedback is very necessary for us. So please fill the feedback form without fail. So now we are glad to invite our essential resource person, Dr. M. Mary Shanti Rani ma'am. Associate Professor, Department of Computer Science and Applications, the Gandhigram Rural Institute, deemed to be University, Gandhigram. So she has 70 public